Welcome back to the Let's Code Java channel. My name is Alex and I'm a senior Java developer. Today we are continuing our professional area calculator project. In this lesson we will enhance our architecture and clean up the main method. We will achieve this by implementing three essential design patterns: registry, strategy, and factory. You'll see how these patterns work together to keep our code modular and easy to extend. Let's start coding. First of all, I want to add shape type enum. Enums Java is a specific types that hold closed number of constants. In our example, we have only three of them: circle, rectangle, and square. It's uh, it's more close to integer type because each constant is actually its ordinal value from the start. So circle is 0 based, ordinal 0, rectangle is 1, and square is 2. So you can compare it with double equal sign, and it's more easy than to compare between strings. If you shape type was a string, you have to compare string circle with another string. Also, if it's string, you don't know it must be all capitals, only one capitals, and so on. So shape type come here. Also, the in shape type, because it's type, we can't create instances of this class. It's constants and it's predefined here. So its constructor is private always. So you can see it there with the red lock. So I don't no need to mention it here. It's only private, so I can use it only there in this class. And another type, I can provide static factory for creating these types from string. So create public static from string method that receives input string and creates our enum. We will use it later in when we try to read the console from console our parameters of our shape. So it will be easy for user not to pass something that different from the shape name. So that's why we use this alias property. So we define it that each shape can have its aliases, like circle can also be called as C or circ, or rectangle just in capital R. So it will easy to user to input only shortcut for the whole word. So to parse it, first of all, we validate that input is not empty. That's why we throw a legal exception. Then we use values property that actually the method of Java enum, the return array of all available shape types, convert them to stream and find fast and return it. Now I want to filter it to return only that value that matches our input pattern. Please pay attention that all our aliases in capital cases. So if we add there filter like this, it will be enough because all our aliases capital cases, and once we capitalize our input, it can do the job. So this is the shape type class. Now let's see how we use it. We actually use it in planner shape. We edit this shape type as private member. We make it final as previous one, so it must be initialized in constructor. So we pass it as parameter of constructor and set it like there. And also we create getter for it for future usages. So in in circle, we pass shape type dot circle. It's obvious, very simple. In square, we pass shape type dot square. So in rectangle, we need to add shape type dot shape type dot rectangle like this. Now let's see how our calculator will change. In our interface, we have, okay, in our abstract class area calculator, now it's abstract class, we have member called shape type. It's also final, so it's protected constructor that used with other calculators, circle, rectangle, and square will use, and it just set it. And we add method called support shape that check it's not null and its type actually equals our type, shape type. And we have here helper method shape not supported when we create illegal argument exception according for this shape, just extracting its name from the class and format it there. The shape cannot be supported. So let's see how we use it in circle area calculator. Pretty simple, just pass in constructor shape.circle. Super means call constructor of the base class area calculator. In calculate area, we add this condition that support shape with shape. So if it's not supported, it's a easy comparison of enums, then try to instance of uh, casting. So we do it first and the logic same intact, and at the end we throw our exception that we prepared using our base class from array calculator. So word super comes here that signals that this method are created in array calculator class, not here. Square array calculator. Same pattern, you see super shape type square. If super support shape and shape instance of square, get side, calculate, and throw exception, and then rectangle. We have the same one with the rectangle here, and the instance of rectangle, support shape, and that's it. Okay, so what we did till now, we modified our area calculator and all its inheritance. We also modified these shapes. We added the property and getting modified constructors and all this, but we didn't but in main, because all our changes were private, we did it inside the class and inside implementations, and in base class that used only its successors. In our main class we leave it intact and it's still working. So if I will try to run it, I can do it. Circle 15 and it's working. So this is the open close principle that means that implementation must be close to its class and it must be open to extensions so we can add another one. It's a very helpful issue. Now we want to also reshape this class, so we go to console. We created new package called console and we create console shape creator as it also will be abstract class. We defined private protected member scanner, so we will use it in its descendants with its protected constructor, the same way as we do it with area calculator. And we don't use member shape type, but we use abstract class get shape type that return shape type, because it abstract, it makes all its successors to implement it. So each one will return the specific shape type. And also we have abstract create shape method that each one will implement it in this way. So let's look on console circle creator. Okay, get shape type, return shape type circle, create shape. It prints return radius, uses super scanner to read its radius and create circle instance. Very simple here, because our scanner is protected in the base class, we can use this field in in its class here with super words. You don't require to use super words. It also will work fine, but for simplicity and for more readability, you can edit there so you know exactly that scanner located in console shape creator and not in this class for large classes as the important thing. Another one, let's see, square creator, get shape type will return square. Our constructor just call the super one and create shape, use also super scanner to read the side. And let's create our rectangle creator here. So we will call it on same convention console rectangle creator. That will extend console shape creator. So okay, I can do it. So I can no, I want I want this one, and implementation will be shape type rectangle, and here will be we just copy this, we just copy this logic here like this with super scanner like this and super super scanner like this, and we just create return it. Okay, what we missed, matching super. Okay, so it must be public, we want to use it in any places. So we just implemented another one. So open from open close principles, make it simple to create another one. So you see in 2 minutes we create this one. Also, we will create a registry part and class that actually will help us to get quickly to our specific console shape creator. So we create a console creator registry class with map that will hold as a key shape type as value console shape creator. Java map as the key value pairs with almost like complexity of one access point, like array. So we have register method that receives shape type and creators and just put it in map, put a websend. And we have get method that will try to get from our map our console creator according to shape type. Very simple class. And now we will see our factory class that will actually do the job. So our factory class actually we will create the planner shape with create shape method like this. Will receive shape. So shape, it will use shape type from string to create shape that we used enum, and then we use creators as our registry to get shape and create shape. So in one line we can do two things. You also can split it to two lines for more readability. And in our constructor, we create registry and we register console circle creator and console square creator. So we need to register another one, new like this, very simple extension. And now we are ready to modify our main method. So let's try to work. First of all, we need to create our console shape factory like this. Okay. He needs scanner. He needs scanner. Okay, input. Now we already have string shape, so we create planner shape like factory create shape. So we already created, we don't need these ifs. And the last part, we we need to create our calculator, so we add init method private static list area calculators create calculators that actually will return our calculators new, these ones. Okay, what's wrong with it? What's wrong with it? Okay, my bad, sorry. Arrays as list, or we can use list of. There are a bunch of options, so new like this. So this will calculators, and here we go. Create list area calculators. Okay, and we also use stream. And C calculate area shape. Find first Y calculate area planar shape. Find first if present system out, and that's it. And that's it. So you see it's very simple. So let's try to run it to make sure it's working. And also we can use our shortcuts for our figures. So for rectangles we can use just R. So it's working. As you can see, we can remove this line. Let's try it with another one. Let's try it. Circle was SQ, I think. Yes. 10, and it also working. So that's for today. We've seen how our architecture can evolve by moving logic into a dedicated console creators registry and using strategy pattern for area calculators. The most important takeaway is that even though we significantly change the internal structure, our main method remains stable and clean. We can even run it. This is the power of encapsulation and the open-closed principle in action. Try it in a new shape on your own, like the triangle, to see how easily it fits into this paradigm. If you have any questions about registry, factory, or strategy patterns, leave a comment below. In next video, we'll move to step 3, exception handling, where we'll make our application robust and production ready. Don't forget to subscribe. This was Alex with Let's Code Java. Happy coding!